Thank you for having me. On the TV right now, this is my heartbeat. Right now, live. It is a little higher than usual. It's about 60 usually. So a little higher. It's going up. That's fine, everything is fine. This is normal. The reason why my heartbeat is slightly elevated is that this is going to be a lot of demos with hardware, and it's still going up. It's still fine, still fine. The thing is, this is experimental technology, and it may not work. So last year I also did this talk in a conference in London, and it actually didn't work. So I have a picture of that.
Gotcha. All right.
So I'm happy it works. It's already going down fine. Just to demonstrate, this is actually my live heartbeat. I'm going to take off the heartbeat monitor.
And you're dead.
I'm dead. So this is already going better than last year because the first demo worked. So this is a Bluetooth heart rate monitor, and I got my heartbeat. I got them right. I got it straight with the browser from the device, without any extra things. It's just an API in the browser. I'm going to show you how that works, and I'm going to talk about Bluetooth in general a bit. So let's start. So we're going to have some fun with Bluetooth. But first question, why? So we have progressive web apps, and they're really, really great. But you get things like add to home screen. You can actually you have proper applications running in the browser, but they're not looking like web apps. They're actually looking like applications. But there's one thing that PWAs can't do. So because they are using web technology, they are limited to what the browser can do. That means that you're limited to web technologies. You can talk to servers. Web is great for that. But actually talking to hardware, that isn't really possible. Well, up till now. So why would you want to talk to hardware? Well, I have all these apps on my phone to talk to a light bulb or talk to some other device, to set it up, a remote control, which I need to download an app for on my phone to install it, to pick out the devices I want to control. And I don't want to download 500 megabytes on my phone just to do that. I don't want to turn on the lights using an app that was built 5 years ago somewhere in China and may not work anymore, or was never updated for my screen size of my phone. It's just a horrible experience. And I'd like to turn on the lights using my desktop machine. And they only created an Android app for it, or an iOS app. So there's a good reason that we want to have the same capabilities as mobile apps in the browser. So, Bluetooth. Usually when I do a talk about Bluetooth, the first thing everybody says is, Bluetooth sucks. And that was true. So then you're thinking about classic Bluetooth. That's a 20-year-old technology, a 20-year-old standard, and it was really crappy. You had things like pairing that was a nightmare. Batteries went down pretty quickly. It's a whole different thing from what we have now. It uses the same name, but it's actually completely different technology, and it's modern. And you can control drones and other cool shit. It's known under many names, unfortunately, like Bluetooth Smart or BLE or Bluetooth 4, and now we have Bluetooth 5. But it's all the same thing. It's Bluetooth low energy. And there are 10 million devices shipping with Bluetooth technology every single day. So this is the most common technology that is used by IoT devices, like mobile phones, computers, but even serious applications like glucose monitors, activity trackers, IT devices like light bulbs, cute little toys like BB-8 robots, or a drone, for example, fidget spinners, never mind. But before I show you some of these things, I'm gonna have to tell you some boring theoretical stuff. So first, there are two types of Bluetooth devices, central devices and peripherals. A central device is a device that connects to other devices. It can be one, but it can be more. So a central device connects to a peripheral, and not the other way around. A peripheral can't connect to your central device. Like I said, you have a central device that can connect to multiple devices, even at the same time, but a light bulb can't talk to your drone, for example, because they're both peripherals, but it is possible for the central device to relay messages between them. But that is something you have to create on the central device yourself. And we're not talking about Bluetooth low energy in general, but a very specific profile of Bluetooth low energy, and it's called the generic attribute profile, which has a very obvious abbreviation, GATT, because GAP was apparently already taken. Now we're not talking about central devices anymore and peripherals, but clients and servers. So your light bulb is a server. Yeah, that I had to wrap my head around that for a bit, but it's kind of logical.
It's weird.
It's weird, but
I thought it was the other way around.
yeah. So the light bulb offers a service, light. So it's the server. And your client, your browser, we're talking about WebBluetooth, your browser talks to servers on the internet, but also Bluetooth devices. So it's kind of logical, perhaps, maybe.
No, it is.
Yeah. So I mentioned services. Services like light. So a Bluetooth device offers actual services like device information, which is a standard, and light, which isn't a standard. Or a drone has device information and battery, which are both standards. And we have flight control, which is specific to the device. Device information, battery, again standards, and steering control. A heart rate monitor might have device information, battery, and heart rate, which is again a standard. Or if you buy a really crappy one, it isn't a standard and it doesn't offer battery and device information, so it's all dependent on the device itself. If you buy a slightly more expensive one, you do get the standard versions. So a service has characteristics. Like device information has things like manufacturer, model number, serial number, hardware revisions, and so on. You can have multiple characteristics per service. So you can think of it kind of like this. The server is like an array of objects. The service is an object in that array. A characteristic is a property of that object, and they have a value. So this is more what we're used to, arrays, objects, properties, and values. But it's kind of like the same thing. Kinda. It's only different words for basically similar things. Yeah. So services and characteristics don't have a name like an object has, of a property of an object has, but they are identified by UUIDs. They are 16-bit or 128 bits, and they look like this. So this is device information, it's 180A, or a very long version of that, which I won't repeat. We have battery service, which is 180F. And light, well, that wasn't the standard, so it doesn't have a standardized UUID. They have to pick one themselves. And it has to be a UUID of 128 bits, and it has to be outside of this specific range, because this range is used for the standard. They can't use 16-bit, but they do anyway. So if you start playing with this, expect, well, ID conflicts, but yeah. So instead of looking like this, device information, manufacturer, model number, it looks like this. So this is what you're going to see, and you have to make the translation to what these names, these IDs, actually mean. So this is bad for readability and understandability, but it is really good for saving bandwidth, and bandwidth on Bluetooth network is limited, so this is a good thing. So if you have a characteristic, you can read the value of it, you can write a value to it, or you can get notifications, which is kind of like add event listener. And every value is an array of bytes. So there are no fancy data types, it's just bytes. So, phew. How does this look? Well, I have an app, and I can inspect Bluetooth devices with it. If I connect to a light bulb, for example, we have this one. You can see it holds all kinds of different services. Device information, for example, or a battery service, and I can say it's 90% battery level. But there are also some custom services, the non-standard ones. And this one has all kinds of characteristics, but I'm particularly interested in one, the top one. It has 4 bytes. So what if we write a different value to it? For example, 00FF0000. The light bulb turns red.
Cool.
So if we write 0000FF00, the light bulb turns blue. No, green. Sorry, green. Let's try another one. 000000FF is going to be blue. Yeah, blue. So these are RGB. 1 byte for every color. But what is the first one? So if we change that to FF and the rest zeros, it is white. So there are 4 LEDs inside of this light bulb: white, R, G, and B. And you can change the intensity of each of those LEDs. And if you mix intensities, you can basically create every single color There is. Like HTML color codes or CSS color codes. This is the same thing. So, while we're talking about bytes, this is something we know. So this has been boring facts about Bluetooth. Now the fun part. Fun with Bluetooth. But first, the WebBluetooth API. The fun part is coming. Don't worry, don't worry. So, we need to connect to a device. We need to have an API for that. And there is navigator.bluetooth.requestDevice for that. And you can call that with a couple of parameters, like filters, which basically tells the browser what kind of device we want. We can filter on device name, or we can filter on which services must be available. There are many things to filter on. And we must specify all the services we actually are going to use. So, if you execute this function, you'll get a pop-up. And it lists all the devices that are following these filters, are following these restrictions. I filtered on the name. It has to start with playbulb, and there it is. And now the user has to manually select that device and click pair. This is a very important part. This is security. Because you don't want web pages just to start looking at devices in your home and start connecting to them randomly. This is something the user has to do themselves.
Good catch.
And then you get a promise back. But promises are so 2017. Let's use async await. So we can await the promise from request device, and we have the device. And then we can await connecting to the GET server, there it is again, GATT, and we get a server. And then we get a primary service by specifying the UUID of the service we're going to use, and we have a service. And then we can await getting the characteristic, again with the UUID that we're going to use, and we have a characteristics. So this is a little bit more verbose than just going through an object, but it's still basically the same thing. Once we have a characteristic, we can write data to it. For example, call write value with an array of bytes. RGB values, and we leave the white LED, we leave that off. So with this function, we can basically write every single color to the light bulb. It just has to be a value between 0 and 255. And we can read data by calling read value and await that, and then we can pull out the bytes of that array. So I'm using function get uint8, that is from the typed array specification. And get notified of changes, I said that's kind of like add event listener. Well, it actually is add event listener. You call add event listener with the value characteristic value changed, which could be shorter, but still.
Always that one?
Yeah. And then you get a callback. And that callback contains the event, and the event has a target, and it has a value and can get the bytes. Now this isn't useful for a light bulb. But if you have a heart rate monitor, you do want constant updates. Now to save space, to save bandwidth on the network, you have to manually start notifications. So if you don't call start notifications, you're not going to get those events. So if you don't need them anymore, you can call stop notifications. So the things you need to know to play with this, well, the WebBluetooth API. And now you all know the WebBluetooth API because this is 90% of the specification. This is all there is. Well, there are a couple more functions, but I haven't used them. So everything I'm going to show you is something you can do yourself. Now you need to know promises, or even better, async await, and typed arrays. So while researching this, I did find some funky parts. Well, I mentioned that light, for example, isn't standardized. And that means that basically every single light bulb uses its own standard, which is not really helpful. So we already went over this one. This one is easy, it's just 4 bytes. I have a couple of other light bulbs. I have this one, and it's a little weird. The order of RGB that we need to write is a little unconventional because it's GBR. There are other bytes in there. Well, it's probably not visible to most of you, but there are actually 5 fields here, and every field has a switch, which can be 0, 0 or 0, 1, that turns off or turns on the LED, and followed by a value of the intensity. But why you need a switch, I don't know, because if you set the intensity to 0, it's also turned off. So, and there are just 5 fields, but there are 3 LEDs, so 2 of them are not used. Which is probably because there are different versions of this light bulb. One that also has a cold white LED and one that has a warm white LED. But this one doesn't. So, and I said characteristics and surfaces are kind of like objects. Well, in this case, so far, yes. But up till now, because this time you can write to it, but you can't read the value. So it's like a black box, you put stuff in it, but you don't know what happens. And you just hope the color changes. This one is a little bit more complicated, because every single value in this array has to be exactly this. Otherwise it doesn't work. I don't know why. And there's a random number in there because apparently 2 messages can't be exactly the same. So if you have 2 consecutive messages that are identical, the second one is ignored. So there must be a random number in there. And you have to calculate a checksum value, which is, well, not really useful because Bluetooth on the protocol level also has checksums. So anyway, I also have, this isn't a light bulb, but it's a LED matrix.
Oh, cool.
Let's turn it on. But basically 8 by 8, this 64 light bulbs.
Cool.
So you can specify each of these pixels and set the color. So if you look at this example, we have 2 magic bytes, and then we have the position, and then we have RG and B. So this is pretty simple. This works pretty good. I also have another one that's kind of similar, but you need to add some extra stuff. Just to change one LED. Yeah, so I can imagine that if you have one of those devices and there is no documentation, you're not going to figure this out. And unfortunately, for this device, there is no documentation. So, how do you deal with that? Network sniffing.
Okay.
That doesn't work always, but you can buy for 25 euros a little USB key and you can sniff the network data between two devices. It only works for older devices which aren't as secure as the newer devices. For newer devices this isn't going to work. But if you have an older device, like that matrix I showed you, you can use this and you can just basically see what the actual app that the manufacturer wrote does. That's really helpful. But in case of that, yeah, maybe still not helpful enough. Now, for modern devices, you can also just use an Android phone and turn on Bluetooth HCI Snoop log in the developer settings. And then you get a log of all the packets that the Android device exchanges with other Bluetooth devices. And you can use ADB to transfer the log to your computer, and then you can use Wireshark to actually see what happens. And this is really useful, but still sometimes you need to know more, because this is just bytes and you can use the app, and sometimes the app doesn't work really in a logical way, so don't tell anyone. But you can actually decompile APKs and look at the source code that the manufacturer wrote, and that is really helpful. Don't tell anyone. So, now, finally the fun part. Well, at least for you, for me, I'm terrified.
You're at home.
Yeah. So, warning, this is experimental technology. This may not work. Well, probably one of the things I'm going to show you will not work. And Bluetooth uses the same frequency as Wi-Fi, so with many people, many Wi-Fi devices, things may become a bit tricky. So let's just take a moment, take a breath, and let's just get on with it. So, I already did this demo. Let's try the light bulb. I'm going to need to turn it on first, and then I can connect to it. And it actually works. So, now I can basically, by clicking on these swatches, change the color of the light bulb instantly. And it's all going straight from the computer, from the browser to the light bulb. There's nothing in between. Oh, black doesn't work. So this is fun, but oh, it's touch sensitive, so never mind. So what else can we do with this? I can write some CSS. Oh.
Oh. Nice.
Oh, no, this is not right. Navy. I can.
Violent.
Hmm?
Violent.
Sure. But this still feels easy. Animations? CSS animations on a light bulb. So you probably didn't think you were going to see this. No. No. Okay. So let's disconnect. I also have some glasses. It is really hard to see, so. So, Undefined.js.
Oh, nice.
So, there's something else I can do with this. An equalizer, so when I talk, this reacts on my voice, and that is really annoying to my eyes, so I'm going to turn it off.
Is it the browser that's doing the equalization, or is it?
Yeah, the glasses are not doing anything except showing dots.
So it's a microphone on the
So, yeah, I'm using the microphone of my computer using web audio to get the actual data samples from doing fast Fourier transition, whatever, transform. And then I get the values of the volume of each particular frequency, and I just send that as dots to the glasses. So let's try this one, just quickly. I'm just gonna put it over here. And I can basically draw something. And I'm not sure it's working.
It is.
Oh, it is,
It's
yes.
a little slow, maybe because the glasses are still connected.
No, it is slow.
Oh, it is slow.
And it's not because it's Bluetooth. It's not because the glasses are connected. That's all perfectly fine. It is because this device is just slow. What are you gonna do? So this works too. I could try this. Why not? I have a little printer. And I can actually connect to it.
That's actually very
And then when tweets start coming in, I'm using the hashtag JavaScript. It's gonna print something. I'm gonna not with tweeting about JavaScript.
We need a tweet, guys.
Donald Trump.
Trump. Oh,
Get 1 million of them in like 10 seconds.
Forgot the hash? Asking?
Oh, there you go.
okay.
Sorry, I just put your roll just down.
So I'll probably need to buy some new paper. Ouch.
Sorry, I didn't think that through.
Something else?
Just delete Trump from there.
Links are QR codes. It can't keep up. Okay, let's try something else. Let's back to JavaScript. No. images work. Never mind. Next demo.
Fortran or Prolog or.
But it's already
no,
it's working.
It's working. It's working.
Oh yeah,
so.
you're getting JavaScript. Yeah.
Good.
Oh, I actually meant to stop the printing.
Yeah.
It's like theoretical physics or something.
Let's just. Still cached. Doesn't matter. Okay. So I have one more thing to show you. Well, a couple of things. I have this Lego car. It used to have an IR transceiver here with an IR remote, but I exchanged it for a Bluetooth receiver. It's not by Lego itself, but it's you can buy it in stores. And nowadays, the new Lego power function system also have Bluetooth receivers. So they also work, well, not this protocol, but a slightly different protocol, but it also works with Lego devices straight from the store. But I'll show with this one. Of course, I need to turn it on first. And then I can drive around. Slightly slippery. So now it's broken. But I always tell my 4-year-old, if it's broken with Lego, you can always fix it. And that's kind of true. I have some spare parts, but I don't know. Still works. So what can we do with this? CSS animations? Bigger table.
Just in case.
Just in case, sure. So, well, to be sure, I have here keyframe with an animation. I am using CSS variables to specify a direction, but there's also forward and reverse. So let's just change that on this table to just left and right. Right. So it shouldn't go forward or reverse anymore. And let's remove this one. There's a 2-second delay for me to get to the device. Whoa!
That's the missing part from.
So this is the first time this happens. Let's try again. Okay.
Okay. Nice.
All right.
You can get a choreography there.
Yeah, you can basically tell the device to drive through a room, but from this table that's not gonna work. So you probably noticed this Lego head here. So this thing contains a device called a Nordic thingy, and it contains all kinds of sensors, like a gyroscope. So this is the Nordic thingy, and let's calibrate it. So if I move this, so I could use that to control the car. So I'm now connected to both devices at the same time. So this is really tricky. So I'm not going to try my luck. So I have two of these Nordic thingies with me. The company that created them, Nordic, was happy to send me a whole bunch of them to give out to people who would like to play with this. So if you're interested in this, after the talk, come up to me and I may have one or two to give away.
Very nice.
So just one more thing. I brought this with me. And a LED ring and a very, very small microcontroller. This is just 1 centimeter by 2 centimeters. And this thing runs JavaScript.
Oh.
Yeah. If I connect a battery to it, nothing happens. That is supposed to happen. Because this thing isn't programmed yet. So basically, this is just a Bluetooth chip with an ARM core, and it runs the JavaScript interpreter on the Bluetooth chip itself. It is amazing. So what I can do is I can program it to be like a candle that flickers, that sparkles, that and I can set the name of the device. I can provide which services it offers and which characteristics it offers. And I've chosen the exact same ones as this device. And then I have a value, and that value is a color, RGB, and we have it is writable, and if we write to it, we can set the color to the value that just came in. So I created a function called sparkle, and it basically takes that color and sets that color to each of these 24 LEDs with slight variations and turns a few off. And it does that using set interval every 200 milliseconds. So this is just 80 lines of code. have a problem. Window, zoom, sure. Now I can connect to this little chip. And I can send that code to the device. And it immediately starts working. So, just like the program said, it flickers the LEDs, turns random LEDs off, and sets the color. And that means I can basically put it in there, and we have a candle written in 80 lines of JavaScript. And because I gave it the same services, I should be able to connect to it. Now, this is the moment it goes all goes wrong, because I probably have to take the power off and put the power on again, and it's there. And it picks up the color, and I can set it to every color I want with just 80 lines.
It keeps running the code.
And it keeps running the code.
Awesome.
And with 80 lines of JavaScript, we created a more advanced version of this thing. Well, yeah. So, I mentioned I had two Nordic thingies. One of them is a sensor, like this thing, and one of them is running JavaScript. The same Esperino as running on this chip. So that means I can also turn it on. I can also change the color of this thing. So I have two versions of the thingy, and that is it for no. I have one more tab. I mentioned drones in the beginning.
Oh,
Prepare the text. Yeah.
So I brought one with me.
I'm gonna sit down.
So
Put your helmet on.
Yeah.
I'm not sure this is actually going to be safe because the ceiling is quite low, and so the people here closest to the drone, if it comes near you, duck. There's this big emergency button on screen. It's there for a reason. Basically, if it flies on top of you and I push the emergency button, it falls out of the sky on top of you. But at least the motors won't be turning, so that's good. So, here goes. This, I've never done it in a room like this. This is just... So it takes a minute to boot up. There it is. So this is my second drone. Let's put a little passenger on it. So the first drone killed some plants. My wife wasn't that happy about it.
The passenger survived, right?
Well, then it almost decapitated the passenger, and that little guy wasn't happy about that. But yeah, I had to buy a different one. So I'm not trying to scare you or anything, but okay. It doesn't work. This can happen. No worries. Whoa, oh. So
Nice.
So now I need to land, but this isn't helping. So this is a lot of fun. Slightly dangerous, but still a lot of fun. But of course, it also has very serious applications. This is not just flying drones and driving cars. So one of the pictures I showed you was a glucose monitor, and this can, for example, be used for remote healthcare to send data to your doctor without installing any apps, just using the browser. I think this technology has a long way to go. So for now it's just in Chrome, but other browsers are starting to pick this up too. And I think this is the future of the web. Well, one of the futures of the web. So, thank you.